Hey guys, welcome back to another video about statistics. So I'm gonna talk about statistics today because it is a very important part of data science. So if you wanted to do some analysis or if I wanted to go through some data and look at the distribution of the data, so if I wanted to work on any kind of data and we need to learn statistics must. So that is a reason why it plays a vital role in terms of data and data related things and also in data science. So along with the technical tools like Python and other things, and we must need to have a proper knowledge on statistics and advanced statistics. So let's start our session by introduction to the statistics. Basically, statistics is a branch of mathematics that deals with collecting, analyzing, interpreting, and presenting and organizing the data. So everything is a data. For example, if you are talking about TV news channels, TV shows, or daily newspapers, or if you are going to any shopping, something like that, everything is a data. So it has to be collected first and analyzed and interpreting and presenting, at last organizing the data in an order. So that is what statistics means. And it is a crucial tool in various fields such as science, business, healthcare, social sciences, and many more. The primary goal of statistics is to understand patterns in data and to make informed decisions based on data analysis. Let me give a use case example. For example, I have sales data for let's take Amazon. So we just I got the raw data. I wanted to look at the data, how many sales as per the region, as per the country, as per the city wise. So that is a use case. So the primary goal of this statistics is to understand patterns in data and to make informed decisions based on data analysis. So basically, we have two types of statistics. One is descriptive statistics, and another one is inferential statistics. Descriptive means entire population, and inferential statistics means taking samples from the entire population and doing some analysis on the sample portion and interpreting with the entire population. So we'll talk about later about this inferential statistics. So in statistics, data can be categorized into different types based on their nature, characteristics. So we have four main types of data. I mean, different types of data like categorical data, numerical data, something like that. In numerical, a continuous, discrete, and categorical data means anything it representing in a category wise, a male, female, yes and no, for example. And if I talk about sales also, if sales are represented in region wise, region A, B, C, D. So these are called categories. So if I have a data in this categorical manner, that is the data type is like categorical data. So basically, so we have main four types of data. Out of four, the first thing is nominal data. Nominal data, nothing but it is also known as a categorical data, consists of categories or labels with no inherent order or ranking. For example, example cases are like male, female, eye color. Like some people have some blue eyes, green eyes, brown eyes. So if I'm working on a data which is related to the people and by describing their eye colors, uh, then I have this kind of data. It is blue, brown, green, something like that. So da- that is categorical data, but there is no order and type of fruits: apple, banana, orange. So we cannot say apple is greater than or less than or equal to banana, something like that. So in nominal data, so the categorical data without any order, proper order. So that is called a nominal data. And ordinal data represents another data type is like ordinal data. Ordinal data represents categories with a natural order or ranking. The difference between categories may not be uniform or measurable. So the ordinal means same categorical data with some order. Example like education level, high school, bachelor's, master's. So there are some levels, right? The high school, then bachelor's, then master's. The data is a categorical data, but there is a order in it. And for example, whenever we went to any restaurant or any movie theater where they wanted to give us a feedback, like it should be in good, bad, something like that. So satisfaction level, poor, fair, good, excellent. So that is again comes under ordinal data. And rating scales 1 to 5, 5 star, 1, 4 star, 3 star. So if you are working on anything like that, that comes under this ordinal data, a categorical data with some order, meaningful order. And the other type is like interval data. Interval data represents numerical values where the difference between any two values is meaningful and consistent. Interval data nothing but a numerical data. So, however, there is no true 0 point and ratios of values are not meaningful. So, example cases like temperature measured in Celsius or Fahrenheit. And example cases like 20 degrees, 30 degrees, and years also 2020, 2021. So, if you these are all comes under interval data. So, it should be in some intervals, numerical data with some intervals. And there is no true 0 point here. Like if we are talking about years, there is no 0 year, right? So something like that, interval data. And the next data is like ratio data. Ratio data is similar to interval data but has a true 0 point, indicating the absence of quality being measured. Ratios of values are meaningful and all arithmetic operations are valid. For example, height, weight, age. So these all income, number of customers, number of items sold. So here true 0 is present. It has a true 0 point. So that is again one more data. So we do have four nominal data, ordinal data, interval data, and ratio data. And the characteristics of different data types, like nominal data only allow for qualitative analysis. Qualitative analysis, nothing but a data with some categories commonly used for frequency counts and percentages. And ordinal data allow for qualitative analysis. Qualitative, nothing but data which contains some categorical values analysis, as well as some quantitative comparisons using ranks, rank 1, rank 2, rank 3, but some quantities. But those are present in categories only, but the quantity of that categories can be used for median calculations, mostly this ordinal data. And interval data allows for quantitative analysis. Addition, subtraction operations are valid, but multiplication and division are not possible in interval data. And ratio data allows for a most extensive range of statistical analysis. All arithmetic operations are valid here in ratio data, including ratios and proportions. So that is the four types of data we have. If you are talking about entire statistics, we might come across different types of data. So it could be one of these four datas. It could be nominal, ordinal, ratio, or interval data. So next thing, and choosing the right statistical analysis. The type of statistical analysis you choose depends on the type of data you have and the research questions you want to answer. Here are some general guidelines, like nominal data, use frequency tables, cross tabulations, and chi-square test. like what kind of measures we can take if we have these kind of data. So if I have nominal data, we will use frequency tables, cross tabulation. These are the methods. And ordinal data, if we are coming across, if you are coming across ordinal data, we will use non-parametric tests like Mann-Whitney U-test. So uh, so we will use these kind of tests. And if you're talking about interval and ratio data, we will use parametric tests like t-test, ANOVA, regression analysis, and correlation analysis. So basically, understanding the type of data you have is crucial for selecting the appropriate statistical methods, above statistical methods based on the data we have, and drawing solid conclusion from our analysis. Okay, let's jump into the descriptive statistics. The one of the uh, one of the two methods, sorry, two types of statistics. The first thing is like descriptive statistics. Descriptive statistics involves summarizing and organizing data so that it can be easily understood. It provides a way to describe the basic features of data in a study. Basically, descriptive statistics, it describes the entire population. Here the populations means my entire data. So we do call it is like an acronym, like entire data we do call as a population. The descriptive statistics, it will talk about entire data. uh, so when it comes to the important thing, the measures of central tendencies, mean, median, mode. So first we'll start with the mean. The mean is also known as the average, is a sum of all the data points divided by the number of data points, and provides a measure of central location of the data, but can be affected by extreme values, outliers. For example, uh, I have a list of numbers. So that is why the purpose of doing this session in Jupyter Notebook is like, along with the theory part, I wanted to show the use case, how to apply these things by using Python codes. So that is the reason why I mentioned everything in the Jupyter Notebook, and at the same time the codes also. So if I have so how to compute the mean. For example, so I have to import the numpy as NP because I am doing some mathematical operations. So my data is like a list of numbers. I have 1, 2, 2, 3, 4, 5, 5, 5, 6. I just wanted to know the mean of these 9 numbers. And the simple syntax is like np dot mean, and you should pass the data, then we'll be able to get the data. So mean is nothing but sum of all these numbers divided by the number of data points. So sum of these numbers is like 1 plus 2 3, 3 plus 2 5, 5 plus 3 8, 8 plus 4 12, 12 plus 15 uh, 12 plus 15 27, 27 plus 6 33. So 33 by 9 is something around 3.666. So that is what we can calculate the mean, the sum of all the data points by the number of data points. So just sum all these data points and divided by the total number of data points. And if you are working in a like any data, and if you wanted to calculate by using numpy or Python, so this is the syntax to compute the mean value. And the median, next is median. And median is the middle value in the data set. When the data points are arranged in ascending or descending order, if there is a even number of the data points, the median is average of the two middle numbers. So basically, I have so arrange the data in the order. So first thing, if I wanted to measure the median, the data points should be in a order. And if the total data points are like even numbers, for example, I have 1, 2, 3, 4. So if I wanted to get the median out of these four numbers, if the total number of data points are even, then the median should be middle two numbers divided by 2. Like 2 plus 3 divided by 2, which gives 5 by 2 is 2.5 is my median. And if I have the number of elements or data points are odd number, like 1, 2, 3, 4, 5. By default, 3 is the middle value, then that will become my median. So that is the example here. If the number of data points n is odd, the median is the middle value. And if n is even, the median value average of the middle two values. So gives the middle point of the data less affected by outliers, useful for skewed distributions. So I mean, there is no much effect on outliers. For example, I have outliers nothing but, for example, I have a data 1, 2, 3, 4, 5, and I have also 10, which is the outlier. Like this 1, 2, 3, 4, 5 are like not outliers, my main data, and I have 10 along with 1, 2, 3, 4, 5. 10 is nothing but outlier. And if I calculate the median value for this, I'll get a median, but that will not, the outlier effect will not be there, will not affect much in median. But whereas if I talk about a mean, the outlier will affect the mean value, because I have to add the all the values and divided by the number of data points. It will affect my mean. So the advantages of median is like it less affected by the outliers and useful for skewed distributions. So this is how we can calculate np dot median. Then the my data 1, 2, 2, 3, 4, 5, 5, 5, 5, 6. So here my median is like 1, 2, 3. I have 9 numbers. The middle value is 4. So that is why I got 4 as a median. So if I run this, then my median value is 4. So we have 4 numbers left side and 4 number right side, and the middle value is 4. So obviously the 4 is my median value. And next is mode. The mode is the value that appears most frequently in the data set. And a data set may have one mode, more than one mode, or no mode at all. Indicates the frequency value, useful for categorical data to see the most common categories. Mm, for example, let's take this data points 1, 2, 2, 3, 4, 5, 5, 5, 6. Mode is nothing but the most occurring value, most frequently. Here I have 5 3 times, so that will become directly my mode. The advantages of mode is like it is very helpful when working on categorical data. For example, I have a data of people with the one column as a gender. So male, female, male, female, male, female. It was categorized as male and female. Then if I wanted to see more, I mean, population as per the gender wise, I can apply this mode. Then I'll be able to get the number of population as per the gender. So like this is like a use case. That is why it is very useful while working on categorical data to see the most common category. So let's see. So I'm importing stats from Skyfi, which is a scientific tool. When if we wanted to do any statistical operations or anything, we need to import Skyfi, then import stats. And if I wanted to, I mean, calculate the mode out of this data 1, 2, 2, 3, 4, 5, 5, 5, 5, 6. I have to get the 5 because 5 repeated 3 times, my mode will become 5. So if I run this, so here count is 3 because 5 repeated 3 times, that has become my mode. So in the given data points, my mode is 5. So let me represent. So these are like we just calculated by passing a data point. Some data points I passed 9 data points, and I just calculated mean, median, mode. So if I wanted to look at the same data in a visual manner, visual representation, so this is how it looks like. Okay, so for the same data, 1, 2, 2, 3, 4, 5, 5, 5, 6, and I'm trying to draw a plot histogram by using this data. And so now I mean, I mentioned mean, median, mode with some colors and styles, so that it will give me some nice or like information. And also, so this is how you can see. So this is the dotted value is the mean. So my data points are 1 to 6, right? 1 to 6, and out of 6, if I calculated the, I mean, if I apply this above syntax, and it will show me the clear cut idea. See, this is where the my mean value present. So basically, as we discussed earlier, the mean shows the central tendencies, like central value of the data. So you can see the central value, and this is the mean. And also, if you look at the median, so this is the median, because we have odd number of data points, and the 4 is the middle value, and that is where it got present. The median value is 4, and the mode is 5, most occurring or most repeated data point. So this is the mode. So this is the data distribution. This is how my data, my sample data is distributed, something like this. So this is how you can apply some syntax, and we can see this mean, median, mode with the visual. So isn't it good? So this is the mean, this is the median, this is the mode, and this is how the data distributed. Histogram with the mean, median, mode, and this is the frequencies. Like number 5 repeated 3 times, so that is the reason why here it is the number of the data points with the frequency occurrence. And number 2, number 1, 3, 4. So it will give us a nice central tendencies, detailed central tendencies like mean, median, mode. So this is the visual representation of central tendencies. So this is like, if you are talking about formulas, statistics formulas, mean is nothing but a sigma I 1 to n and xi by n, which is nothing but sum of all the data points I started from 1 to n. So if I have n data points, it will be calculated from x1, x2, x3, x4 till xn divided by number of data points, and x bar is like mean value. So this is a formula to calculate the mean. And so we are not yet spoke about variance, so we will talk about here. And so let's jump into the measures of dispersion. Then we will come back to this formulas, and we will discuss. So measures of dispersion describes the spread or variability within the set of data. They provide insights into the distribution of data points around the central tendency measures, mean, median, mode. The main measures of dispersion are range, variance, standard deviation, and interquartile range, IQR. So basically, this measure of dispersion describes the spread or variability within the set of the data. It spreads around the central tendencies like mean, median, mode. So first we'll start with the range. Range is nothing but if I have some data points, the difference between the maximum and the minimum values in the data set. A simple measure of overall spread, but cannot be affected by it. It can be affected by outliers, because like if I give the same example 1 2 3 4 then 10, then I will get a range 10 minus 1 is 9. Again, it is it can be affected by outliers. So the range will be affected by outliers. The range is nothing but the difference between maximum value and the minimum value. So here example where I have the same list 1 2 2 3 4 5 5 5 6, and the range value is like np.ptp data. And if I wanted to calculate the range, it should give me 6, the maximum value, minus the minimum value. The range is 5. Okay, let's jump into variance. Variance measures the average squared deviation of each data point from the mean. Average squared deviation of each data point from the mean. It gives a sense of how much the data points differ from the mean. Indicates how the data points are spread out from the mean with the squared units. So basically my variance formula is like, see, the xi is my data points minus and the mean of that entire data, it squared by the n minus 1, the variance formula. So this is how you can calculate the variance, and it will give me, variance will give us the sense of how much the data points differ from the mean. Each data point will, how much it is differ from the mean value. So here it is a sample example. I just take this same set 1 2 2 3 4 5 5 5 6, and I wanted to calculate the variance. So np dot var for variance of data, then I'll be able to get the variance. So basically it will be calculated by this formula, sum of the data points minus the mean value squared by n minus 1. And here, like if I have 9 points, 9 minus 1, then that will calculate me the variance. So this is about variance. And next thing is like standard deviation. The standard deviation is the square root of the variance, providing a measure of dispersion in the same units as the data. More interpretable measure of spread in the same units as the data. So standard deviation is like a square root of variance. So this is my variance formula. If I apply square root, then it will become a standard deviation. The each single data point differs from the mean and square of that value. So that is the standard deviation. And if I wanted to calculate the standard deviation of my given data, this data, the formula is like np dot std. Std is for standard deviation, then data, then my standard deviation is 1.632. So this is how we can calculate the standard deviation. And the next important thing is like entire interquartile range, IQR. So this is very important thing whenever we are working on any machine learning algorithms, and we, if we wanted to working on null values, or filling the null values, or again one more thing is like if you wanted to look at the relations, correlations, that time the interquartile range is very useful to identify and remove the outliers. So basically it uses to identify the outliers, and then we can remove it, and then we can apply the suitable machine learning model. So the interquartile range measures the spread of the middle 50% of the data. So it is the difference between first quartile 25th percentile and the third quartile, which is 75th percentile. IQR is equal to Q3 minus Q1, which measures the spread of the middle 50% of the data. So if I wanted to calculate from the given data, so my Q1 is like NP dot percentile and data, and I wanted 25 percentile. So I passed 25. Then Q3 NP dot percentile data comma 75, and also I wanted 75th percent or 75th percentile. So if I the difference between 75th and 25th percentile will give me the middle 50% of the data, then that is my interquartile range. So if I run this code, then I'll be able to get 3. So for this above data 1 2 2 3 4 5 5 5 6, the interquartile range is 3. So if I wanted to visualize the same this measures of dispersion, where range, variance, standard deviation, and interquartile range. So this is my syntax. I imported matplotlib and seaborn, and I'm using box plot because it will give me a nice idea about outliers in box plot, and also histogram for I just wanted to see the mean median mode also. So this is my uh, graphical or visual representation of above details. So this is the box plot with IQR. So this is box plot will give me IQRs, like IQR is like Q3 minus Q1, right? So this is the, if I take this is Q naught Q1, and Q2, Q3 like this. Though this middle 50% is the IQR. This box represent the interquartile range. So they, if I have any data which is not in this interquartile range, here if the data present here or top of this above, top of this above, something like that, here or here, we can consider them as a outliers. So this is the visualization for like identifying outliers with the box plot. And also, so same thing, like if I wanted to see, this is the mean value and this is the median, you can see how the data distributed. So, and if I talk about the uh, range, this is the range. 6 minus 1 is nothing but 5 is the range. And you can also calculate variance and standard deviation for each data point, like uh, mean of this, like how each data point varied from the mean. For example, if my mean is like 3.7 or 8, so 1 minus the difference and square by number of data points. So that is how you can calculate the variance, and square root of variance will give me standard deviation. So that is how you can see this measures of dispersion in a visual manner. So this is about descriptive statistics. It is very important whenever we are working on a smaller data sets, like we need to do some calculations on entire population. So central tendencies nothing but mean, median, mode, and the measures of dispersion is like a variance, range, standard deviation, and interquartile range. So this is about descriptive statistics. And next thing is inferential statistics. So next topic is inferential statistics. Inferential statistics, nothing but we are drawing some conclusions based on some samples. So inferential statistics involves making predictions or inferences about a population based on some sample data. It helps in drawing conclusions and making decisions based on data analysis. So whereas in descriptive statistics, it gives us the description about entire population, but here the inferential statistics. So for example, if you are working on very large data set where it is not possible to like calculate the mean, median, or central tendencies on entire population, in that scenario we will take some data. For example, let's take this exit polls for normal election cases. Or so in that case, we will take some sample data, then we will draw some conclusions out of it. We'll do some analysis on that sample data, then we will interpret or the sample data analysis to the entire population. So that is the one a small example when it comes to inferential statistics. So you can see the image. So inferential statistics means if I have this a larger population, then I will take some sample and the appropriate uh, conclusions regarding the population's features. So inferential statistics applied on a sample of the population. So I'll do some analysis on this sample and I'll draw some conclusions and I'll make some decisions based on the data analysis on the samples. For example, suppose you wanted to know the average height of adult men in a certain country. For example, let's take India. So I wanted to look at the average height of adult men in the entire country. I cannot go to each and every person and I cannot take the data, right? That is impossible. So in that case, you could take a sample of men, measure their height, and then use inferential statistics to estimate the average height of all adult men in the country. So that is how we should take some samples from at least 200 or 300, or let's take 1000 men out of entire country. Then we will calculate or we'll do some apply this inferential statistics and we'll estimate the average height of all adult men in the country. So the important thing is like sampling. The sampling is like inferential statistics are based on sampling only. So which involves selecting a subset of data from a larger population to represent the population as a whole. The sample data is used to make inferences about the population. So like, so if I take this sample, I do some analysis on this and then I'll draw some conclusion about the population by doing some analysis on this population. Okay, so this will give me like statistics divided into descriptive and then inferential. Since we're talking about inferential, in inferential estimation is one thing and hypothesis testing is one. And in estimation, we have point estimate and interval estimation. So we are going to talk about it now. So estimation in statistics. Estimation is a crucial aspect of inferential statistics, which involves making predictions or inferences about a population based on a sample data. There are two main types of estimation: point estimation and interval estimation. So estimation is nothing but we are going to draw some conclusion based on a sample we have taken from the population. So we are going to draw a conclusion conclusion about a population based on the sample set. The point estimation is a single value that serves as an estimate of a population parameter. It is derived from sample data and represents the best guess for the unknown parameters. Common examples like sample mean, used as the point estimate for population mean. Whatever the mean I got for the sample, so it will estimate the population of the mean. And some sample proportion used as a point estimate for the population proportion. Sample standard deviation used as a point estimate for the population standard deviation. For example, so if we have a sample of 100 students and their average test scores, and the 85 is the point estimate of the population mean test score. So like, for example, I have sample, only I have taken 100 students and their scores, and I got a mean value or average value is 85. Then 85 will become my point estimate of the population. If my population is more than 100, it could be like 1000. Then I'm concluding like the population average or mean also could be 85. So this is if I wanted to look at by applying to some data. So my data is 1 to 2 my sample data points, and then if I apply the mean, then it will become my point estimate of the entire population. So here I calculated the mean. Mean I got 3.666. This will become the point estimate of the entire population mean. This is my sample data, not the entire population. I have taken this sample from the entire population and I just calculated the mean. This will become the point estimate of the population. And the next thing is like interval estimation. An interval estimates provides a range of values within which the population parameter is expected to lie, with some intervals from here to there, something like that. It gives more information about variability and uncertainty associated with the estimate. The most common type of interval estimate is confidence level. The confidence is level is nothing but the confidence level is a interval estimate computed from the statistics of the observed data, and it is likely to cover the true values of the parameter within a certain level of confidence, usually expressed as a percentage. Example, 95% confidence interval, something like that. So for example, if we calculate a 95% confidence interval for the average test score and get 82 and 88, this means we are 95% confidence that the true entire population mean test score lies between 82 to 88. So whereas in point estimation, we are concluding sample mean as the point estimate for the population. Here we are just taking some ranges like interval from here to here. So I draw some conclusion that the population mean or average scores may be from 82 to 88, something like that, not a point value. So here we can see with this syntax. So I have taken a sample data 1, 2, 2, 3, 4, 5, 5, 5, 6. Then I calculated the mean and I calculated the standard deviation. Now I wanted to calculate the confidence. Confidence level I am giving 95% and Z score something like that. If I apply this, then I'll get a confidence level from 2.5 to 4.7. Whereas here, if I calculate the mean value, I got 3.66. But here I got it, the confidence level of 95%, I got it from 2.5 to 4.7. So this is how you can calculate it. And this is the code for estimation. You can see, and for the same data, and it will give me some point of estimation and also the confidence level. And if I look at the same thing visually, so 95% confidence interval for the mean. So for my given sample data, my mean value present here, and this is a lower bound and upper bound. Lower bound is like 2.53, something like that. So here we got lower bound 2.53, right, in confidence level. So that is why it is 2.53, and upper bound is like 4.79. So here my upper bound is present. So, and these are all my data points in my data points. So this is how you can look at the data visually for confidence levels and point estimations. These are all my data points. I have 0, 1, 2, 3, 4, 5, 5, 5, 3 times, 2, 2 times. Okay, so next one is hypothesis testing. Hypothesis testing is a statistical method used to make decisions about the properties of a population based on the sample data. It involves formulating a hypothesis, collecting and analyzing data, and then making a decision about the hypothesis based on analysis. Null hypothesis, the statements that there is no effect or no difference, which we seek to test against the alternative hypothesis. So let me give a simple example. I have a list of or set of students. I have 5 students, and I before apply or before like see my example is like I wanted to conduct a test hypothesis testing on a set of 5 students. Then I took the test scores before any training. Like normally I have taken some scores, and I also taken some scores after some training has provided. So before the training and after the training, if there is any difference, if there is any significant difference in the initial and also after the training, then that means there is like that is where this hypothesis testing comes. So null hypothesis, like the statement there is no effect. So here before that any training session conducted, and if there is no significance difference, like previously the all the students marks are like 80, 85, 90, 95, 100. Even after providing the training also, if they are getting the same scores, then there is no effect, right? There is no difference which we seek to test against the alternative hypothesis. Alternative hypothesis means the statement that there is an effect or difference. So null hypothesis means there is no significance difference, or so alternative hypothesis means there is a significance difference. For example, for the same 5 students, if they are getting more scores, then that is a positive. Then if they are getting low scores even after providing the training, means that is again negative. But if there is any significant difference, then that is where the alternative hypothesis comes. So basically it will be useful in the healthcare, like whenever if new drug is introduced for a disease, and if there is any significant change in the disease with that particular drug, then we can use this hypothesis testing, like is there any significance difference or not before and after. And that is where we will use the significance level alpha, the probability of rejecting the null hypothesis when it is true, commonly set at 0.05 or 5% significance level. And where we will also calculate the p-value. P-value nothing but the probability of obtaining the observed data, or something more extreme. If the null hypothesis is true, a smaller p-value indicates stronger evidence against the null hypothesis. Test statistic, a standardized value that is calculated from sample data during a hypothesis test. So These are all the steps in hypothesis testing. So state the hypothesis. Null hypothesis is like mu not. Alternative hypothesis is like which is not equal to. So here null hypothesis means before and after there is no significant change. So before the training and after the training there is no significant change. The mean value average scores of the students before the training conducted or after the training conducted, the means are equal. There is no significant difference. That is where the mu is equal to before and after is equal, and this is before and after is not equal. Choose the significance level alpha we need to choose. Then we need to calculate the test statistic. For means use z test when population variance is known, or t test when population variance is unknown. So based on this, we need to use the z test or t test. We do have some test hypothesis testing. So based on the conditions, if when the population variance is known, then we will use z test. If the population variance is unknown, we will use t test. And we need to determine the critical value p value, compare the test statistic and critical values from z or t distributions, or calculate the p value. Then we will make some decisions. Reject null hypothesis if the test statistics falls in the critical region, or if the p values is less than alpha. Fail to reject the null hypothesis if the test statistics does not fall in the critical region, or if the p values is greater than alpha. So let's take one sample t test, then we will calculate. So this is my sample data, and my mean is like 3. Sample mean and standard deviation I calculated, and calculating the t statistics. So I got t square as 1.15 for the above data set, and now determining the critical value or p value. Now this is how I can calculate the p value. P value is equal to into 1 minus the above calculated value. Then I got 0.281. Then I'll make a decision. If alpha is 0.05, if my p value is less than alpha, then I have to reject the null hypothesis. If it is if it is greater than, then fail to reject the null hypothesis. Since my alpha is like less than, sorry, greater than 0.05, then fail to reject the null hypothesis. If the p value is less than 0.05, we reject the null hypothesis and conclude that the sample mean is significantly different from the population. So if there is any significant difference, then we will conclude that the mean is significantly different from the population mean. If the p-value is greater than 0.05, we fail to reject the null hypothesis and conclude that there is no significant difference between the mean and the population mean. And this is example 2 sample t-test where we have 2 samples. Above we have only 1 sample t-test, and if we have 2 samples, we can calculate p-value and we can conclude reject or alpha. So this is how we can do for 1 sample, 2 sample. So that is how you can calculate the hypothesis testing with the p-value and alpha. Then we will draw some conclusion whether to reject the null hypothesis or not, if there is any significant difference. So the main importance of this statistics are decision making. Statistics provide a basis for making informed decisions in various fields by analyzing the data trends and patterns in predictive analysis. For example, if I wanted to predict future stock price, or uh, house price, future house price, something like that, it allows for predicting future trends based on the historical data, which is essential in areas like finance, like stock price, marketing. It could be like real estate or weather forecasting, like we can forecast tomorrow's weather based on the historical data. And quality control in manufacturing, production, Statistics are used to maintain quality control and ensure product meets certain standards. So medical research also, like I gave some example, drug example, where it has some meaningful or significant difference if I take the drug, something like that. So that is where we can use this statistics, analyzing medical data and determining the effectiveness of the treatments. Statistics in everyday life. So for example, like I said, polls and surveys used to gather data on public opinion and consumer preferences. Sports, analyzing player performances, team statistics, and game outcomes. Education, accessing student performance, educational research, and improving teaching methods. So this is like normally how we used Python for statistics. So as it is a powerful programming language widely used for statistical analysis due to its simplicity and availability. So we can calculate these methods by using NumPy, Pandas, Matplotlib, Seaborn, and SciPy. And NumPy provides support for large multi-dimensional arrays, as we discussed in a separate video, and Pandas and Matplotlib also. So same thing we discussed above. I have just taken one sample and I have calculated mean, median, mode, standard deviation, variance. So with the box plot and a normal histogram. So this is about statistics. I hope if you are getting something, if you are looking for any statistical methods, or if you have any confusion in statistics, I hope you got some answers after watching this video. So if you are having any questions, please do let me know so that I'll be able to clarify. So I hope you're understanding and liking the videos. So please do subscribe the channel. So that is what we covered so far, all descriptive to inferential statistics by hypothesis testing. And I also visually represented my central tendencies and dispersions. So that is the video, guys. Bye everyone.